The James Webb Space Telescope was launched to answer one of humanity's oldest questions: where did we come from? But in the process, it may have revealed something even more profound. Since its first deep-field images, Webb has been sending back data that has shaken cosmology to its foundations. It has captured light from galaxies so distant, so ancient, that according to everything we know, they simply shouldn't exist. These galaxies appear hundreds of millions of years too early, fully formed, massive, and bright, at a time when the universe should have been a quiet, dark void. If the data holds true, then something extraordinary is happening. Either the timeline of cosmic history is wrong, or the universe itself is far stranger than we've ever imagined. According to the standard model of cosmology, the universe began 13.8 billion years ago in an event we call the Big Bang. Space expanded from an unimaginably hot, dense state into a vast and cooling cosmos. For the first 100 million years, there were no stars, no galaxies, just hydrogen, helium, and gravity weaving the first patterns of structure. Astronomers call this era the Cosmic Dark Age, but Webb has pierced that darkness. Its infrared eyes have reached farther than any instrument before, revealing galaxies that existed when the universe was less than 300 million years old, some possibly only 100 million years after the Big Bang. The discovery has stunned scientists. At that age, there shouldn't have been enough time for galaxies to form, and yet the images show systems that look mature, dense, organized, and shining with the brightness of fully developed stellar populations. One astronomer said it was like finding skyscrapers standing tall before humanity even discovered fire. Faced with these impossible findings, scientists are divided. Some think the distances might be miscalculated, that the galaxies aren't as old as they appear. Others argue that Webb's instruments are precise, and the problem lies with the model itself, not the data. Among the boldest new ideas comes from researchers at the University of Portsmouth, who suggest that our universe might not have begun with the Big Bang at all, but with something called a big bounce. In their model, our cosmos could have formed inside a black hole in a much larger parent universe. The concept is breathtaking. When a massive star collapses into a black hole, gravity crushes it toward infinite density. But quantum physics provides a counterforce known as degeneracy pressure. This resistance can halt collapse at extreme densities. The team proposes that the same principle applies to universes. When a previous universe collapses, this quantum pressure triggers a rebound, a bounce, that births a new universe on the other side. To observers within, this rebound would look exactly like a Big Bang. In this view, every black hole might be a doorway to another universe, and ours could be one of countless generations in an infinite cosmic cycle. This theory has profound implications. It could explain why Webb's galaxies appear so massive so soon, because the universe may have inherited structure or matter from its parent, allowing galaxies to form almost immediately after the bounce. And yet the black hole model is only one of several competing explanations. Some scientists favor the idea of a cyclic universe, one that expands and contracts endlessly, each collapse giving rise to the next creation. In that case, the Big Bang was not the beginning, but simply one moment in an eternal rhythm of birth and renewal. Others turn to quantum gravity, which suggests that space and time themselves have a grainy, discrete nature. If that's true, the early universe could have evolved differently than our smooth equations predict, allowing galaxies to grow much faster.
There are also those who believe the mystery lies closer to home, in our measurements. The distances to these galaxies are calculated using redshift, the stretching of light as the universe expands. But redshift depends on knowing precisely how fast space itself is growing. And recent studies show discrepancies in the expansion rate, the so-called Hubble tension. If we've been misjudging that rate, then our estimates of these galaxies' ages could be off by hundreds of millions of years, making them less mysterious than they seem. Even so, Webb's observations have reignited one of the deepest questions in physics. Is our universe truly uniform and isotropic, or is there a hidden order behind the chaos? Some studies of galaxy rotations suggest a subtle alignment in the way galaxies spin, as if the entire cosmos has a preferred direction. In a perfectly random universe, rotations should be evenly split, half clockwise and half counterclockwise. But that's not what the data shows. This cosmic asymmetry hints at something deeper, perhaps that space-time itself is twisting on a scale too vast for us to comprehend. This idea connects to Einstein-Cartan theory, an extension of relativity that includes a property called torsion, the intrinsic spin of particles woven into the fabric of space-time. Under extreme conditions, torsion could generate a repulsive force, preventing singularities from forming and turning black holes into engines of creation rather than destruction. In that case, every black hole could give birth to a new universe inside its event horizon, each with its own physical constants and geometry. Our own cosmos might be one such offspring, expanding within the boundaries of a black hole that exists in a parent universe beyond our comprehension. It's a staggering notion, but not everyone is convinced. Many physicists caution that while these ideas are mathematically elegant, they remain speculative until we can test them. Others point out that solving one mystery often creates another. If our universe was born inside a black hole, what birthed that parent universe? If time cycles endlessly, who set the first cycle in motion? Every theory seems to stretch the limits of what science can currently prove. Meanwhile, more cautious astronomers are looking for simpler answers. Some argue that Webb's bright, ancient-looking galaxies might be optical illusions caused by gravitational lensing, the bending of light by massive objects along the line of sight. Others think early galaxies could appear unusually bright because they contain populations of giant, short-lived stars that burn hotter and faster than today's suns. But even with those explanations, not all the anomalies go away. Webb continues to uncover objects that challenge every model of cosmic evolution, structures that seem to form too early, too fast, and too large. Each new image deepens the mystery rather than solving it, and in the process, it's forcing science to expand its imagination. What all these theories share, from black hole cosmology to cyclical models and quantum universes, is one breathtaking theme. Our cosmos might be part of something much larger. Perhaps the Big Bang wasn't the beginning, but a transition. Perhaps time itself has no true start or end, only endless transformations. Or perhaps the multiverse, long dismissed as a fantasy, is the natural outcome of a universe that never stops creating. In that view, every black hole is a gateway, every collapse a new creation, and reality is an infinite web of worlds giving birth to one another forever.
The James Webb Space Telescope wasn't designed to answer these questions. It was built to look deeper into the past than ever before. Yet by doing so, it has brought us face to face with the limits of our understanding. Each red dot of light it captures is not just a snapshot of history, it's a challenge, a whisper from the edge of time, asking if we truly understand what we're looking at. Maybe the galaxies Webb sees aren't errors or illusions. Maybe they're hints, evidence that the universe is older, stranger, and more interconnected than we dared to imagine. Perhaps our cosmos is just one chapter in an infinite story, a single heartbeat in a living, breathing multiverse. For now, scientists can only debate, test, and wonder. The telescope will keep watching, its mirrors catching ancient photons as they cross the gulf of time. And as they do, we may come closer not just to understanding where the universe began, but to realizing that it might never have had a beginning at all. Because in the end, the James Webb Space Telescope hasn't just shown us the early universe. It has shown us how little we truly know about existence itself, and how every discovery, no matter how small, is another doorway to infinity.